Now, if we compare example 1 to the warm-up, example 1 is actually a little bit different. Now, if we go ahead and graph this, we have 1 over x squared. Well, we still have a horizontal line and at 0, at y equals 0, and a vertical asymptote at 0 as well. The only difference, though, is that because we have a squared item like that, anything that we plug into for x, whether it be positive or negative, is just going to actually end up coming out to be positive, because when you square something, whether it's positive or negative, it'll just be positive. And so we should see, we'll go in green, we should see a graph that resembles something, oh boy. We should see a graph that resembles something like this. Again, it's not going to be perfect, but you should kind of see a shape doing something like this. And then on the right, it's hugging it as well. Oh, that's awful. And then on the right, we see it hugging. Again, just a rough sketch, but you would see an image doing something like this. Now, when we look at the limits, well, if we look at the limit as x approaches 0 from the left of this function, we see that it is going upwards towards positive infinity. We can see it right here. As you approach 0 from the left, it's going up to positive infinity. Likewise, which by the way does not exist, this would be a DNE. Likewise, as you approach 0 from the right, it is going upwards towards positive infinity, which again does not exist as well. And as a result, then the limit as x approaches 0 of this function, well, it does not exist, but there is something special and unique about this one. Notice that they are both ending up at the same value, positive infinity. Well, then we can say that the limit as x approaches 0, not left or right, of this function is going to infinity. It's still not existing, but we can kind of give it the general direction of what's happening. So that's a little bit more powerful than what we were able to do with our warm-up. And so that's just something to keep in mind. You know, if they end up going at the same spot or meeting up at the same place, you can go ahead and say it is in fact meeting up at infinity or negative infinity, depending on the function. All right. So just kind of keep that in mind. They do not exist still, but you can be a little bit more specific. By the way, when you're saying either infinity or negative infinity as like a final answer, not plus or minus, but as a final answer, you are implying that the limit does not exist. However, this is a bit of a more specific answer because you can at least talk about, again, the general shape of the graph and where things are going. So again, that is example 1 from our 1.3 set of notes.